Hello, everyone. It's great to be here in Santa Cruz. I'm really glad that I was able to make it to the ACM meeting. Obviously, I'm not there. I'm actually in Barcelona, but I'm very happy that we're doing this virtually so people like me can attend these things. So thank you, people physically, for dealing with all the weird extra stuff that's involved with having these sorts of events. One of the great things about having these events is that we can also have people join us from places far away. Looking at least 3 of the panelists, I've noticed that you're also not in the room, which is very, very cool. So normally around this time, I have things like code of conducts and Chatham House rules, but as far as I'm aware, you're already at a conference and you already know those things, so I don't need to repeat them. However, I will say that online participants, please use the chat. Use it as much as you want. It would be really, really cool to have a live chat going, because that's a great way to asynchronously follow along. For those of you who are presently there, please do not use the chat unless you feel like it would help you somehow to be on your computer. You don't have to do that. I will, at the end of the session in which the people are talking, read out questions, and you can also raise your hand, and then Stephanie will help direct those questions to me, the facilitator, in which I will ask them again for the recording, just to make sure they're there if they're not clear, and then we'll go straight into question and answer when that happens. I think most people at this type of conference have been alive for the last 5 years, and so none of this should be a surprise. And if it is, DM me privately and let me know if I'm messing up. But with all that having been said, it is great to be here. So this is a cool panel. It's on OSS for reproducibility. We have an abstract, which is fun. And I could read the abstract out to get you really excited about everything. But we actually have a speaker who's going to be introducing everything anyway. So I'm not going to do that. Instead, I'm just going to say who the speakers are and have them identify themselves. So first off, we have Malvika Sharon, whose name I may have mispronounced. Malvika, can you say hi?
Hi, that was perfectly pronounced name. I'm Malvika Sven. Hi, everyone.
Malvika is joining us as a senior researcher from Open Research from the Turing Way, which is a really awesome community of people dedicated to figuring out how do we do reproducible science. And she'll talk more about that. That's followed by Sayeed Choudhury. Sayeed is director of the OSPO at Carnegie Mellon University. Many of you may have already experienced Sayeed from his work at Johns Hopkins University or through OSPO++. Sayeed, are you present and does your mic work?
I am here, and I hope my mic is working all right.
It seems to be. Thank you for being here. We're also, of course, joined by the illustrious, illimitable, and wonderful Stephanie Leege, whose name I still mispronounce after years of knowing it.
Right.
Oh, I did it right. Okay. Stephanie is the ED of the OSPO at UC Santa Cruz. Again, that's mainly for the people who are not already at the session. Stephanie, it's great to have you here. You are sounding fine. And our final open source scholarship strategy at Stanford Data Science Initiative. Zach, how are you doing today?
Hey, Richard, and hello, everybody in Santa Cruz.
Excellent. Okay, so those are the people who are going to be speaking for the next hour and a half. If that is a surprise to you, I'm sure there's other places you could go, but I hope it's not, and I hope you enjoy being here. So that's great. Sayeed, you have the wonderful opportunity for the next 25 odd minutes, which is roughly until the hour, to talk about what's going on here. So I have open source software and open science as the general bullet heading, but I'm sure you have actually done your prep work. So I'm just going to hand it over to you, and good luck.
Thank you, Richard, and thanks for the opportunity to be here. It's a pleasure to speak today, and I do hope we keep it actually under 90 minutes so that we can get some discussion and have some conversation with you in the room and online as well. So what I'm going to do is try to set the broader context around open science, particularly in the US context, and particularly in the context around the federal government and federal funding agencies. I think there's some really important developments that are worth keeping in mind. And, I think rightly or wrongly, sometimes when people think about reproducibility, they think about an individual investigator or a small lab team that know each other and sort of have an implicit understanding of the practices that are going on and the workflows. But I also want to mention sort of the rise of team-based science in conjunction with open science and why I think those are important developments. So really, I'm setting context, maybe raising some questions. I think, my fellow panelists will have some specific ideas around those. And then, as I said, hopefully we can get some discussion going. So let me go ahead and share the screen to get my slides going here. Can somebody give me a verbal confirmation that you can see my slides?
Yep.
Excellent. All right. So the first relevant memo, if you will, or sort of policy announcement in this context is something that happened, over a decade ago at this point. And it's called the so-called Holdren memo. Came out of the Office of Science and Technology Policy in the White House in February 2013. And it was really the first prominent statement around so-called public access. Now, it's important to note in the federal government, they don't use the term open access, but rather public access. And this memo was basically stating quite clearly that for certain funding agencies, I believe it was over 100 million or 150 million, something on that order of budget, those agencies were required to come up with policies and recommendations around public access. And that was quite a significant development in the community, if you will. Nothing like this had come out before. So it got a fair amount of attention. About 10 years later, last year, there was sort of an update. This is a distinct and separate memo. It's not, like Holden Part 2. But it is a building on that previous memo that I just described. And this came out when Alondra Nelson was at the Office of Science and Technology Policy. It did a couple of really important things. One was affirm some of the things from the original memo in 2013. It also updated some of that. So one response, whether, I don't think it was intended, from publishers with that first memo was basically asking for embargoes. So there was some period of delay before articles became available. This update has basically said there will be no more embargoes. Articles need to be released and available upon publication. It also affirms the importance of data as one of the important research outputs for which there needs to be public access for things that are funded. And it actually makes it now applicable to all federal funding agencies, regardless of level of budget. In conjunction, in parallel, I worked with some people at the Software Engineering Institute at Carnegie Mellon. The Department of Defense, they are the Department of Defense's sort of a think tank advisory group for software development. The Department of Defense for some years has been thinking about open source software, and last year came up with this. It's called a memorandum, but in all practical purposes, it is a policy around open source software. And it has many, many elements, but the ones that are probably most relevant today are that either from the consumption of open source software or production of it in the Department of Defense, one must be open by default. And there are, of course, many security issues, and I'll come back to that a little bit later as well, and many other considerations, supply chain issues, so on. But the default is to be open. And why I think this is so important is that the Department of Defense can take a posture that we can be open by default when it comes to software. Then I'm fairly confident the NSFs of the world, the NIHs of the world can't argue that, wow, we have all these conditions that don't allow us to do that. So I think the DoD setting that, putting that proverbial stake in the ground is really important. From the White House itself, there was an announcement earlier this year that this year will be the year of open science. If you're familiar with NASA's program, the Transform to Open Science, in many ways that was the precursor, the inspiration for this. But it is now a multi-organizational, multi-agency announcement. So several funding agencies and even some agencies that aren't necessarily directly funders like NIST have endorsed this idea and are all working towards 2023 being the year of open science. So this is a very strong signal from the federal government at the highest levels that open science is now an important priority, and the funding agencies themselves are lining themselves up in order to respond to this. And I do end up spending a lot of time reading federal documents, which is not necessarily my favorite activity. But one of the things I'll mention to you is that sometimes, maybe more than sometimes, the federal government says a lot, but goes to great lengths not to actually specify anything. So I think the fact that there is a definition of open science in this announcement is really important. And this is a very brief snippet of it, of course, but I think a very important one where reproducibility is front and center. So the federal government is saying 2023 is the year of open science. We believe it's important for various reasons. There's been this culmination or progression, and reproducibility plays a key part of that. It's not only a US phenomenon or trend. UNESCO, which for those who don't know is the United Nations entity, primarily on cultural heritage, but also has this definition for open science. You can read it just as easily as I can. I've highlighted some of the elements that I think are important. So this is a signal that while the US has its own trajectory, certainly Europe does. I spent some time at Carnegie Mellon's campus in Qatar, the Middle East does. This is a trend that's happening throughout the world. This is not just something that is confined to the US. And of course, science doesn't necessarily have borders. So it's not as if you can say we'll be open in the US and not open in Europe. It's ideal to have some sort of, if you will, coordination, or at least some sort of intentional communication. This is the second part of that definition. What's interesting is they say, this point about all scientific disciplines, not only the hard sciences and engineering, but the humanities, the social sciences, and built on these four key pillars. So this is really, again, an affirmation or a signal of a worldwide interest and trend in open science. Within the US, there are some actual federal policies and memos and mechanisms that are moving forward to affirm this as a reality. This is a picture of Jen Easterly. She is the director of CISA, which is the Cybersecurity and Infrastructure Security Agency. She gave a talk in February at Carnegie Mellon. If you've not read this transcript or seen this talk, I would encourage you to take to Google it and take a look. She called it unsafe at any CPU speed. There are many things she talked about, but the main sort of overarching message was, once upon a time, if you drove a car and you had an accident, you got hurt, or even worse, you died, or someone died, it was kind of decided that you're just a bad driver. That's kind of your fault. And if you look at what happened over a few decades, we shifted that, burden, responsibility, accountability to the automakers themselves, right? And you now have an entire, sort of ecosystem around building cars where safety is paramount, and it's thought of intentionally. Some companies even think of it as a brand or an advantage, if you will. They are the assembler of all the components. So if you have a problem with your tires, you don't go to the tire company, you go to the car company. And if there's an accident, then the auto company may be liable, may be responsible. She's in essence arguing the same kinds of things may need to happen with software, even open source software. So the idea that I use software and something happens, and a company or the federal agency or somebody can say, well, that's your fault. You downloaded, you used it. But if that shifts more to the producers, what are the implications for people who produce open source software, including researchers, including around reproducibility? And probably not a surprise, the point that open source software is now a key part of critical and digital infrastructure. Therefore, security aspects around it, she calls a national security issue. So this is a different kind of attention, if you will, from the federal government, but I think an important one to note. So this is a slide that I often show people, which shows articles on the left, data in the middle, and software on the right. And those arrows between them are supposed to be the relationships. So cited data within articles is sort of a linear, simple relationship. Relationship between data and software is much more complex. That's what the squiggly lines are. And then the lines to the right are what happens when all these things are curated well, and you share them outside of your research lab or even your university. In some ways, all these policies from the federal government that I described have moved from left to right in this diagram. So over time, there's been an emphasis on articles and then on data. And the only reason, I shouldn't say the only reason, one of the reasons why software was not more intentionally mentioned in some of the policies I described, other than the DoD, is most of the funders and most of the federal agencies said, well, we're not ready, right? We're not sure that the funders would know what policies to write and the universities would know what to do. But That won't last forever. It will change, and I think we'll see this move towards software being intentionally mentioned. And you're probably familiar with data management plans. I will tell you that the Office of Science and Technology calls them data and software management plans now. So I think that's a very strong signal that we'll start to see this happen. One point I'll come to a little later is this is a very simplistic view. You know, they're probably more accurate to say software artifacts. There isn't this hard boundary between data and software. And now we have machine learning models and algorithms and so on. And then there's hardware. You know, these are all important components. What does openness mean in that context? And what does it mean from the perspective of reproducibility? You probably remember this, and it may not be a pleasant memory for you. I was the leader of the library team that supported the COVID dashboard when I was at Johns Hopkins prior to CMU. I put this up here because this is a major affirmation, maybe even celebration, now that COVID is over, of the power of open data, right? I'm very, proud that I was the person that on early calls said, we need to use a Creative Commons license for the data that's being used and produced by this dashboard. After some back and forth, we came to that point, and it created a lot of other dashboards and a lot of secondary uses. And then of course, the vaccines that were created around COVID is another huge kind of case study of what happens when you have open science. It's interesting, we can talk about this more, how sharing of code was really important in the development of those vaccines. But I mentioned this because in essence, I've heard several federal funders say, this was fantastic, this is great. This is an example of how open science addressed a major global issue in a very rapid way. There were lots of questions around results being shared and not being reproduced, or how do you reproduce them that quickly? But nonetheless, a real success story in the midst of a terrible time of open science. But the immediate response after that is, okay, what about cancer? You know, what about heart disease? What about diabetes? What about climate change? What about food insecurity? What about, electrification? Why can't this become the model for other things that universities do? We don't want this to be the one case where university research was opened up and led to these societal benefits. We need this to happen in many, many ways. So I think this is a one-way street. I don't think there's any turning back. And I think what happened during COVID is sort of a bellwether event. Prior to my work on the COVID dashboard, I actually spent many, many years at Hopkins working with the Sloan Digital Sky Survey, which is a large community-based astronomy effort. And I bring it up for a couple of reasons. One is it was an incredible opportunity to work on open science because astronomy data by definition is conducive to being open. The lead astronomer at Hopkins who I work with is someone named Alex Saleh. He gave me this, or he showed me this image when I first saw it. And he had this very, some obviously facetious statement where he'd say, astronomy data is worthless. And I'm like, what do you mean? You're an astronomer, why should you say that? And he'd say it has no commercial value, right? It has no restriction, it has no legal issues, whatever. In that sense, we can do whatever we want with it without getting encumbered in all these other conversations. So the astronomy community really embraced openness throughout the work with SDSS. And what this diagram shows is the so-called levels of data, all the way from the top left, which is the telescope itself, all the way to the bottom right, which is a SQL database, which is released publicly in the form of what's called a data release. And there are these steps of processing, and there are workflows that go from the so-called level 0 at the very top to level 3 at the bottom right. Not only does that democratize the way people interact with astronomy data, there are about 10,000 professional astronomers, but there are over 1 million registered accounts for the SDSS data releases. It also has some interesting implications around team science and reproducibility. So there was a particular set of data captured by the instrument that had a calibration error for a few weeks at least, maybe even longer. And it was a group of astronomers who noticed as they started looking and says, something seems to be off, this can't be right. And the team based in New Mexico where the telescope is went back and said, you're right, we had a calibration error, so we need to deal with it. The interesting point is that because it's a team-based open project, they were able to fix it in a cascading way throughout the system, right? They went back and all the articles that cited those data now have, obviously footnotes or whatever the right mechanism is, that these were those uncalibrated or improperly calibrated data. You don't throw it out. You don't say, we don't ever want to cite those again, but you need that context. And then when they fixed it, it went throughout the whole system. So as you think about team-based open science and reproducibility, what might be the implications here in terms of sort of these systematic ways of dealing with reproducibility issues? More recently at Carnegie Mellon, I'm involved with something called Cloud Lab. This is an automated remote scientific facility that started in the Bay Area from 2 CMU alumni. And they created it for small life sciences biotech startups in the Bay Area. But now Carnegie Mellon is building a similar kind of facility, not on campus, but close to campus, which will be used for Carnegie Mellon researchers and then hopefully beyond. And it is what is called minimal human intervention. And it's largely robotics and physical hardware and software and data and machine learning tools and so on that you control from your laptop, that you control from anywhere. It was started off with the Bay Area companies, so it's a closed system. We are now opening it up in the context of working with Carnegie Mellon and other universities. And I can tell you that having worked with astronomers, it is infinitely easier to start off open and close things as you need them than to start off closed and open them up later. So one argument I've given for open science is it just gives you more choices. Nobody's saying you can't have embargoes. Nobody's saying you can't close things up, but you can certainly make it easy to open them up if you wish. But with Cloud Lab, as you think about scale, one of the really interesting questions is what happens when there's more machine learning and more AI happening than there is human intervention, human intuition in terms of the experimentation and the design. And I mentioned this in the context of a National Academy of Sciences report around automated research workflows. It's a very interesting read, but in essence, one of the questions it's asking is, can we move past the current era of sort of machine learning tools helping analyze what you're doing in terms of your experiments and your data to AI actually helping you design your experiments, and to do so in an iterative, real-time kind of way. So imagine in a Cloud Lab environment, you run some experiments, you do the analysis, and you don't take it away, whatever that means, and have a person or a group of people look at it. But in real time, the AI goes and says, these look like more interesting pathways. There are so many permutations and combinations here. You're never going to be able to do these manually or with whatever script you have. The AI can do it though, and then you can process that and think about the next step. What are the implications for reproducibility in that kind of environment? I don't have an answer, but I think this is the kind of thing we'll have to think about. And this is a quote from that report that affirms what I was just saying, that it's not just as a component in the workflow, it's that they may actually design experiments and then automatically control them or sort of process the directions that you move and so on. So I think this is a trend that we need to keep an eye on. So just a few things to think about in this context. This is not meant to be exhaustive in any way. I work at the open source programs office, and often I hear, well, I'll just release my code as open source. I don't think that's enough, given the context I just set. So what will be enough when we think about code? What is enough when you go from the individual to the lab to team-based science? And there's a program officer at the Alpha P. Sloan Foundation named Josh Greenberg, who has this interesting phrase of the rolling wall of openness, that openness is not binary. It's not that you're completely open or you're completely closed. You may be open for a while and then be closed, or vice versa. And some things may be open and others may not. So that's also important. And I'm, preaching to the choir, so to speak, or speaking to the experts. But terms like reproducibility, replicability, what does that really mean? Do we mean the same thing? Is it a technical issue like software builds, or is it scientific in terms of reproducing your results? The growing importance around security, this is not going to go away. Suppose you have to do some remediation from a security perspective that affects your results. How do you have a balance between those two? And then the role of AI and machine learning. In terms of openness, what does that mean? Is it that the data are open, the language models are open, the weights are open, the code is open? I think that's really critical. And then, like we had with the astronomers, there was an issue, it was remediated. There was a clear signal of who would be doing that in that case. But who does this writ large? If these things happen, particularly if AI is doing this in a much faster, more scalable way, who's responsible for actually remediating these things as they happen? So I'll just stop there and turn it over to my fellow panelists, and hopefully we can have some discussion around these topics. Thank you.
Right. Oh, wait, Richard, we can't hear you. Nope. Sorry. That was very dramatic, just you throwing it at.
Can you hear me now?
Yes, we can hear you now.
Okay, good. Yeah. Well, I tried to make it work and it didn't. So let's just
Sorry.
go with the normal voice again. Thank you so much, Sayeed. That's really what I was saying. That was really excellent and super, super good. It also keeps us well for our first question for the panelists. And Zach, I'd like to ask this of you first. Sayeed sort of dived in a tiny bit with reproducibility versus replicability, but I'm really curious what you think the differences are. I have no idea. So if you could help me out, that would be great.
Yeah, I'll pick that up. So the National Academies actually published a report in 2019 that I think might be helpful here. It's called Reproducibility and Replicability in Science. And one of the caveats that they noted is that is a problem of nomenclature and that there is variability by discipline. So they spent some time in the report to kind of call this out. Generally speaking, reproducibility of research tends to be along the lines of computational reproducibility. So given the data that's provided to support a paper, can we, using that data, can we get to similar results? And by replicability, mostly what that means is starting with new data. So replication studies can actually go as far as doing experiments over from scratch, getting new data and then testing whether or not those results hold up. There's the Center for Open Science at UVA has led a number of really important replication studies over the years for psychology, cancer biology, and a lot of their findings point to some glaring holes in the way that science is conducted, and that to sort of underscore some of Sayeed's earlier points, a lot of the failures of either reproducibility or replication come down to the fact that the data was not even available or available upon request, which is kind of code for, maybe I'll give it to you, maybe I won't. But even, so for the 100 or so experiments that they ran over, again, to test these, these claims of these articles, many of them needed the intervention of the original author. So even if in cases where they did provide the data and shared them appropriately, there's still a lot of the method that is unclear, oftentimes in a paper. So there's I could keep going on this topic, but I also want to give some time back to my colleagues. There's a really great paper that I refer to over and over again on this topic, and that is a 2016 paper by Goodman and Ioannidis on the definition of reproducibility. I can get you that citation. The paper is called "What Does Research Reproducibility Mean?" And in it, the authors cover three types of reproducibility. One is reproducible results. That's mostly what people are talking about. The second is reproducible methods. And I think it's significant that they call that out specifically. And then the third is inferential reproducibility. And what that gets at is that can include interventions like replication, but it also, so we put the DOI up, that's awesome, thank you. But it also gets at nuances like different scientists could actually have the same data and come to different conclusions. There's a whole field of study around this, meta science. These are, I think it's good to get into these topics because it also kind of uncovers what we mean locally here, because there can be differentiation by discipline.
Thank you so much. Other panelists, would you like to jump in and comment?
I'll just add quickly again. I'm sorry, Stephanie, were you going to say something?
No, go ahead, Steve.
I'll just add quickly again that I mentioned working with the Software Engineering Institute. This question of the technical side of reproducibility, like reproducible software builds and so on, is sometimes conflated, but sometimes connected. And one of the things that we're exploring with SEI is, sort of this dependency graph, right? Your software has all these dependencies, and I've managed IT teams for many years, and I often hear from them, please don't ask me to update these things because I just don't know what will break. But I think the driver around security is not going to let us just sort of say, it's okay, I'll just keep using old versions of stuff because I know it works and my results won't be affected. But I just want to reinforce that point about as the security considerations grow, we'll have to start thinking more intentionally about how do you make updates to the technology underlying what you're working with, even if it has impacts on your ability to do the other kinds of reproducibility that's just described.
Thank you. Stephanie?
Well, I was actually gonna, I know we're gonna have Q&A later, or a chance to have the rest of the audience talk, but because this was a specific question I noticed from the notes when we were prepping for this panel was about that discussion of what people see as the difference between reproducibility and replicability. Can't even say it, and I'm part of the conference committee. I actually wanted to ask at least a couple from at least the committee if they had some ideas based on, and that maybe differ from what Zach was saying or what Sayeed was saying. And since they're more of an expert on those issues than I am, I was gonna point at my boss over there to make him put him on the hot seat for that question because he's done this to me before.
So what was the question?
The question was, well, the initial question was make it clear, having a clear definition of reproducibility and replicability. And Zach was talking about how what the definitions are from in some fields, but in the context of what we've been talking about, and the keynotes from yesterday kind of I thought had a good discussion about that, and it would be maybe nice for the panel, some who didn't see that, to also hear that.
So I think that I'm actually surprised that we're discussing this, right? Because I mean I think it's good for people to have an understanding, but this conference is actually many of the audience were actually directly involved in that process of defining these terms. And so it's kind of a little bit funny to have the discussion coming from the panel because it's actually settled, right? And I think it's just for us, upon us to actually make sure that everybody has the same understanding, I guess. But the definitions have been settled, right? And so there are some communities who take exception to this. I think yesterday there was an example of a community that does still have a different understanding, but that one of the things, as one of the panelists pointed out, is that the overall goal is to actually have the same understanding across all communities. And I think that, I think we should just move on.
I would actually argue it's not settled. And I would argue it's not settled because the people who are in the room represent the forefront of an entire discipline. we may know what's going on, but there's a lot more people who haven't heard this talk and haven't been to these lectures and haven't read these papers. And so it's our job to figure out, to settle it so much that we can talk about it really easily with everyone else. But I'm very happy to move on.
I'm just saying at this conference.
That's okay.
At this
I
conference.
was using that as a clever segue, Carlos. And the segue was going to be moving on to what is the Turing way and how do they do it, which I think Malvika is well poised to share about. So Malvika, would you mind talking about that?
Thank you so much. I appreciate, Richard, you saying that not a lot of people have heard about this, but also across discipline, it really differs. I know that, Sayeed was talking so much about biomedical data or COVID data. Of course, this looks across the different countries quite differently. One thing before I actually introduce the Turing way, I wish I could share an image because we are such an image heavy project. We talk about research life cycle, and we talk about research life cycle where different stages involve different people. And these different people are involved in ideation of research, in understanding how we're going to design the research, how we collect the data, how we select the different methods, publish them, archive them, and let other people reuse it. In all of these processes, of course, we apply technical, computational, or experimental methods. But because there are multiple people involved, we also need to recognize that there are people who bring personal lived experiences, biases, their own selection towards methods that they want to use, the field that they come from. And all of these add to the replication and reproducibility. So computational reproducibility is very simple to define, and maybe that's what folks in the room in this conference actually understand. But I'm going to add this nuance of that we are people who are doing the research, and hence our activities affect how reproducibility happens. So the Turing way is a project that tries to think about what reproducibility means to different people, meaning what is the responsibility for a PhD student or a postdoc or a funder, government? How are these different stakeholders of research will share the responsibility for reproducibility? We have been running for 4 years now, and we have involved over 450 people at this point to write 300 different chapters describing different best practices in data science. So we are an open science project, which is community-led, where people come together to discuss what practices means to them in their own context. And they describe it in simple chapters without rewriting what people have written. The purpose isn't to reinvent the wheel. We really cite all the folks that you have been talking about in our work. The idea is to really provide a simple introduction to different concepts which generally people find really hard to access. This is to improve accessibility to data skills, so more people are skilled to use them and apply them in their own context, or even reject them and say, yeah, AI is overrated, probably it's not needed for my own research. We had started as a book on reproducibility, where we were talking about version control and continuous integration, containerization, code quality, and everything. And immediately it became apparent when people started to come and talk about different aspects of working together, collaborative and inclusive practices. We had to expand our project into 5 different guides to explain what project design means, how can we consider project design that implements reproducibility at all stages of research. We talk about collaboration and communication as 2 really, really important and really interspersed topics, where we talk about transparency can be improved by documentation. Sometimes people don't really read documentation, so a lot of people also talk about how can we communicate in different formats. For instance, if we are trying to reach policymaker, we might want to think about a policy briefing. But if we are trying to reach a student who is super new to the field, maybe a blog post is really good. Nobody has written about TikTok or Instagram, but I'm sure there are a lot of ways to do scientific communication. And then there's a guide on ethical research, and we try to simplify again how do people understand ethics, even when, let's say, ethical framework is different in different contexts. We also have community handbook because we're working with lots of community and describing all these practices. So our hope is that people are going to take these practices, apply it in their own context, and try to help us improve reproducibility, move it forward. Over the past 4 years, the Turing Way has been used in a lot of high-profile international reports and policies. And we're really working now directly with organizations to understand what implementation looks like. So that's a very short introduction of the Turing Way, and there's a lot that you can read, but I want to just open that up for challenge. Please challenge us, because we're not global perspective, because if your perspective haven't been reflected on it, we're obviously not sharing what you should be telling us about. I hope that introduction makes sense. And again, if this argument for reproducibility has been settled, I'd be really happy to tell that to our readers.
Thank you, Malvika. That's great. It's good to have the Turing Way here, because you're one of a host of other communities that's working really hard to make run books, to make workshops, to try to figure things out. There's other things like NumFocus, there's our Open Science, there's a whole suite of different things that are working together to make it easier for us to reproduce science. Throwing it back to you, Stephanie, I'm curious what tools or thoughts you have based on the introduction of the Turing Way or any of those other suites of tools that are helpful that you use with your students to help them understand how to build more reproducible science. If you could just comment briefly on what do you do to teach those things?
Well, I haven't actually taught, so I think that's a harder one for me specifically. I mean, to answer in detail. I know that there's a lot of push, and I've heard a lot of discussion in this group about the types of tools that are being used in different universities and in different academic settings for teaching this. And we actually had a really good talk in the morning by Frida from NYU on some of her methodology. So I would say that I think it kind of depends on the students that are I mean the different groups you're talking which universities and which fields and disciplines. I know for us, but one of the things I have been working on, so not in the classroom specifically, but is the Summer Reproducibility mentorship program, which is based off of the Summer of Code. And in those cases, and again, that it ends up being very specific to the individual researcher that the students are working with and what tools that they're using. But it's been a pretty, okay, they're only first year, but we have like 16 or 17 students working there. And they are, depending on I think I would say the standard one would be that a professor has created or a faculty member or researcher have created a specific project for them, similar to the way the Google Summer of Code works, that the students are then themselves taking it on as a summer project and creating a reproducible artifact with, and then with a direct mentorship from the researcher that they're working with. And in that way, we're kind of creating a new skill set for all of those interacting that hopefully will create a larger pool of talent and students who understand kind of the importance of reproducibility and the mechanisms for doing it within whatever discipline that they are working on. So I mean, that's what I have been working directly with, and I'm sure there are other faculty that worked that are doing it differently in the classroom. Does that help?
Thank you.
Did I answer your question?
It does help. It does help. Yeah, no, that's great. I want to throw the question out to Sayeed and Zach. Both of you have done work on both coasts that is sort of international in scope, whether it's the COPE map or working with data science in general. And we just heard that there's international aspects to working on science together. And I was just curious how you view reproducibility as being part of that larger discussion.
Yeah, I'll certainly I can think about the international dimension, but I want to come back to that sort of U.S. piece. Another way I would describe some of the context I provided. So let me share a little anecdote. About 7 years ago, I think, I testified in front of a congressional subcommittee, and I came up with an idea that I shared with the congressional staffers. And one of them said, that's an interesting idea. And then he said, but you have to be aware the federal government is a big hammer. So be careful when you use that big hammer. part of the reason I'm sharing the context around all these policies around open source and things that DoD and others are doing is, let's say we have well-defined understanding of reproducibility, replication, and so on. Do you have as much confidence that the federal government is going to know those things when they come up with a policy around reproducibility? Because they will. The fact that open science is becoming such a big movement and reproducibility is part of that, at some point in the future, the federal government is going to have a statement or a memo or a policy around it. And this is the community that needs to be informing that process, but making sure that that happens in a very active and intentional way is really important. And how do those definitions and understanding transfer or transition to this kind of AI-driven world of doing research that the National Academies report described? The international context just makes it even more complicated, right? So if you have different federal, whatever the right term is in Europe and Asia and other regions, coming up with different policies around this, that's going to make it even harder, right, for global team-based science to happen. So I think it's excellent to have a good understanding within this community of what the differences are, what the definitions are. But how do those get communicated to the people who are going to make policy at these larger levels? And how do they migrate over time as the nature of research itself might start to change with things like AI?
So this is something I've noticed for a while now. A lot of our conversations around open science tend to be have national boundaries, but that's not really how science works. So, part of it is a lot of the attention these days is policy driven, and also some of our consortia are national in nature. But if you look at how our faculty collaborate, there's a lot of international collaboration there, and we have really strong open science centers in other countries, not in the US. And, University of Utrecht is one example. The Montreal Neuro at McGill has long been a practitioner of reproducibility for the sake of advancing science. And the faculty director there, Guy Rouleau, once said that we're not pursuing open science for its own sake. We are trying to accelerate cures. We're trying to cure degenerative neurological diseases that currently don't have cures. So we don't have any time to waste. We need to do it all in the open. And Sayeed's earlier reference to COVID-19, I think is a really good example here, because during COVID-19, we had radically open data sharing, something on the order of like 50,000 preprints, sharing results and data immediately. The genome of the virus was shared within 10 days. So we've never had a global project like that. And consequently, we had it translated quickly. We had 4 vaccines in 1 year, which was completely unprecedented. I think the previous record was 1 vaccine in 4 years. So can you imagine if we had to wait 4 years for a first vaccine for COVID? I think we do have to think globally here and include other people outside of our national boundaries. That's how science works. But also there's a global north and global south equity problem here. So the rate at which vaccines were shared in developing countries probably could have been a lot better. And that's something that I think we should look at. And so maybe open science is a way to tackle some of these inequities.
Thank you so much. I'm looking at our list of the third question of possible trends and where are we going, but I feel like we've actually just covered them all. So instead of going forth with that, I actually want to open the floor up so we have more time. Does any panelist think this is a horrible idea and I should resign as a facilitator immediately?
No, I think it's great. And actually, I have a question for the people sitting in the room and those online. So whenever it's the right time to ask that, I'll do so.
It is. Go ahead.
Okay. So the question, I was at Hopkins throughout most of the COVID period, certainly the period of developing the vaccines, and ended up talking to researchers who were directly involved in doing the analysis of the gene sequencing and then coming up with the vaccines themselves. And to Zach's point, there was this very serious concern, right, about lots of things being put on preprint servers, data being shared, and it even hit mainstream press of things that, you know, were then later disputed, refuted, whatever. Were any of the folks in the room or online involved, or do you know people who were involved from your community who were involved in basically helping these researchers say, this is how you can verify this is reproducible, or this is how you can verify this could be replicated, and so on?
Not seeing from the. Yeah, I'm not seeing anybody with that. So,
I would point out, like, I remember around that time, there was some discussion about putting some people in touch, some people on our team, possibly in touch with some of the people that were doing some of the COVID related work, but it never really went anywhere. And I'm curious. Part of me thinks that these people were moving very quickly, but they may not have been familiar with all of the resources that were available to them at their respective institutions where we hadn't already established good networks. Like, I think for as well as it went, and I think it went well, all things considered, it could have been a lot worse, right? So we have to give ourselves credit for that. But I feel like it's not just the researchers that we need to position for future success. It's all the people around them. It's the software engineers, it's the HPC facilities management people, it's the data stewards and the librarians. What are we doing to position these networks to respond better to emerging threats and emerging needs, you know, in the global community, right? I think we need to think more holistically about how we align all of that with these open science objectives. So that would be my take.
yeah.
Yeah, hi, I'm Lynn Pouchard from Brookhaven National Lab, and I remember that there was an effort between several DOE lab. I think it was called Natural Virtual Biotechnology, NVBL effort, where scientists from many different labs came together to work on the problem of the vaccine. Now, I'm not aware that anybody worked on reproducibility at that point. But I have a slide here. It was like Los Alamos, Berkeley, Lawrence Livermore, Oak Ridge, Pacific Northwest, Sandia, Argonne, Slack, and Brookhaven. So bringing different resources together, including computational resources for doing drug triage. There were also characterization in the light source, where they would when the samples were made, it was brought in, and also there was a use of some structural biology for decoding or helping with the decoding of the virus's genome. There were also other efforts brought together with making distributing the technology for making the actual vaccines, not just the product for the vaccine and the test, but also all the little physical devices that were used, making masks. I think Oak Ridge was involved in that. So but that wasn't. I never heard about any reproducibility there.
I don't see anything. Anybody else from the floor have anything? No.
Yeah, I just wanted to jump in a little bit there, and I'm sorry, I don't know who made that point, but I do think it went really well, right? I mean, I think it could have been a lot worse, and obviously I'm biased. I spent most of my career in universities, but I think it was an affirmation that most university researchers are incredibly responsible, and you know, if there were bumps or mistakes, and I don't mean to say that facetiously or euphemistically, they were not intentional, right? I don't think people were out there intentionally trying to cause mayhem or so on. And I think the speed was completely justified, right? You know, to Zach, I think, what did you say? The fastest was 4 years, and we ended up with 4 in 1 year. but I'll come back to this point of what happens in a world where AI is much more involved in experimentation in a full sense of the word. And the speed at which people are looking for more scientific results may trump sort of some of the guardrails or whatever the right term is. And it isn't as, I mean, I'm not an AI expert, but are the applications of AI going to be as predictable and as responsible and as easy to rein in if they have these so-called whatever they're called, hallucinations that ChatGPT is having and so on? I just think that seems to be something that needs to be really thought through, because obviously there's also federal attention on AI, right? And what guidelines and policies need to be put out around that.
I can speak. Sorry. To read a letter to Sandia National Labs, I really do think it's too early for us to tell. I feel like there's a lot of if there are tools out there that can improve the work of researchers are going to use them, right? So we can fully expect that everyone is going to latch on to this, right? With more tools. And we already have a problem right now where researchers themselves will hallucinate results when they look at data and they see what they want to see, right? Let alone having AI do it, right? We already know this is a problem, but I think, I don't know. I just feel like it's a little bit, it's not premature. I'm just thinking, I know for a fact, I've already actually been using AI in my own work, looking into it, seeing if it could actually help me and do work that I would have assigned to a grad student as a character building, snow shoveling exercise, cataloging literature or categorizing interview data or doing other things. It can do it. It can do it very well, actually. And I'm really excited about that. But I think when putting it into the role of the researcher, like leading the experiments, the data analyses and everything else, and putting it in that kind of role, I do not have great confidence, not as of yet, not in those technologies, right? For now, I see it more as an assistant rather than something that's taking the primary role. But that may change in the future.
And to the speaker's point about all the problems that currently exist with bias in research and things that get in the way of reproducible results and all of the things that we know about regarding p-hacking and so forth. This kind of brings me back to I think why this panel was put together around the role of open source software. And I guess I want to come back to reproducible methods. How transparent can we become at documenting our methodologies, and what is the role of open source in that? Is it sufficient? I guess what I'm trying to get is it a sufficient condition to use open source software, or what are the other, all of the other nuanced pieces that go into reproducible methods?
Anyone? Oh, sorry.
Go for it, Stephanie.
Go ahead.
So I was going to respond to that just because we're talking about distributed research and people working across different countries. And one thing that I want to just respond to previous to connect to this answer is that one thing that a lot of researchers have told me that they do not want to forget from the COVID research is to try to do something that they are not set out to do. So previously, a lot of researchers would say, oh, I've got lots of funding, now set a lab in an area that I have no previous experience in and spend 5 years of money in setting something that other lab can do in 2 months. COVID actually allowed that to happen where people trusted other teams in their own ability and knowledge, and they collaborated that way. So more people with complementary skills could work together. And I think a lot of people are now trusting that. And I feel like, not just feel like, I actually do have research papers to prove it, is that when you are working with multiple distributed teams, for example, in big team science, for instance, you have many babies and many dogs, all those big distributed research, people are forced to share their code openly with them. So the other teams that they're working with can actually use it. Sometimes one of the advantage of these distributed work or distributed teams are that people start building inner best practices to share their code, share their data, document their software, so their team members can replicate or run this software that they have been working on. And at the end, this allows them to publish research alongside documented work that they initially built for their own team members or for themselves. So I feel like we need to think about, going back to Zach, when you were saying that, we need to think globally. I think the advantage of pushing for reproducibility through global collaboration and open science is exactly that. We improve transparency for the sake of our collaborators, and that ends up profiting a lot of people who may not have been originally involved. At the same time, when we open up our work for collaboration with interdisciplinary perspective, meaning that people who have not originally had stakes in the work that we are doing, we have to force ourselves to communicate our work in a way that is understandable outside our own field. So for instance, translating my own expertise from data science and AI into a biomedical field where researchers are working with low throughput data, where they are not concerned about AI. It is not important for them. What's important for them is high probable candidate that they can go back in the lab with and identify if that really is the valid result. So I think it's really important to think about when we're talking about reproducibility and replicability in the collaboration. Somehow, when we are going in that direction, it's more equitable, more important in terms of if I have developed a software in a research environment that my collaborators don't have, to think about, can I replicate that in their own system so they are able to run it.
Reed has a comment in the back.
Yeah, sorry, I don't mean to dominate the discussion. I just have a lot of opinions. But to the point about is open sourcing enough? Is there other things here? And I also want to talk on the multidisciplinary part of this, right? We know already that transparency, that's something we mentioned earlier in the conference. That's something we should aim for. Just getting them to do that much, putting everything out there. It doesn't have to be good. Just put it out there. Don't be afraid, right? That's good. But at the same time, open source doesn't mean that it's tested. Doesn't mean that it's documented. Doesn't mean that it's all these other things that maybe There's a question of also getting time, funding, and resources to invest in your software to make it software other people can trust. And trust, I think, is actually one of the real thornier issues here, right? Do you trust this other team, right? Now, there's some part of it like that is something you can mechanically determine, like is it reproducible, you can run the code and everything else, but is that software going to be around tomorrow? Are they going to keep maintaining it? Are they going to keep getting funding, or should you be rolling your own, right? With the risks that come with that, because it doesn't have your software, doesn't have the same pedigree as their software. Right? And this is incredibly important, especially as we move into an era of more multidisciplinary science, multi-institutional science, community-driven science, right? I think this question of trust, and to what extent do we trust versus how much are we skeptical of other people's software, is going to be very, very important.
Okay.
Yeah.
I also want to jump in just really quickly, and then Karsten also had a comment here on the floor, if the panel's okay with that. So I think what I found very interesting when I was reading through our notes on the discussion prior to the panel was that how much I have seen, and especially more from hearing today's talks about how much the push towards reproducibility has come in line with the push towards open and open source software, and how I thought it was very interesting how I'm seeing. I'm in both worlds. I'm not an expert on the reproducibility side, but I hear it talked about a lot in my job. And then on the open source side, I see there's this like parallel discussion, and sometimes it overlaps, but sometimes, and actually I think it does overlap, but not always recognized. So I think what you were saying is really important, because I think that whole discussion about maintaining that we've had, I think was it your talk today? Yeah, right. So very well put, Reed. That really made me think, like, there are so many of the overlapping discussions that we are having from an open source community discussion about how to properly open or be open and how to normalize open, that I feel like we were also having about how do we make reproducibility normalized, and how do we make it easy, like the way Juliana talked about yesterday. And so I think these are really interesting points that, like, I kind of wanted this panel to get that discussion going, which I think it is. And I'm going to call on Karsten, if that's okay with folks online.
You want to take my spanner? I'm tossing Spanner into this.
Oh,
Okay.
of course. Wait,
I'm gonna-
I was like, I think that's, Richard, are you good? I know it's hard to
Richard's
moderate.
wait a moment.
Richard did a thumbs up, so we're good.
Well, I'm going to take kind of maybe even the opposite tack from where Carlos was taking about word definition, right? I want to follow down where Stephanie was going with the word open.
Yeah.
So we keep walking right around that one. We haven't known. Everyone's like, we all know what open means, right? Do we? I don't know. Do you know? Are you familiar with open washing and what happens when people start using that? So, and I just want to flag this. I think that maybe as important as reproducibility and replicability for people to understand, we need that common definition of open, which we have. The Open Knowledge Foundation has created a definition for us that works really well. When Stephen Jacobs was putting together the Open Works definition, we correlated that back to the other definition. Everything lines up. So it's not open source. I mean, honestly, it's not open source science, it's open science, open data, like we're all doing. So there's another thing that we need to be teaching back out into the world, or I'm going to ask what your opinion is on this, teaching the definition of the word open and make it be a standard one. And I think something for us that will help understand, and it's because I've been describing the open source methodology for people for years, and I say, well, basically it's the scientific methodology just rebranded and with some other modern stuff with it, right? So we note that bit, that how quickly we apply scientific methodology turns to open terms. There's a real direct correlation between that. And so I think that, which my recommendation would be to add this to that list of things we want to make sure people know about, particularly the big hammer of the federal government when it comes to, I was reading very carefully that the letters that Sayeed put up, I'm like, oh, those are close. I hope there's, you don't want them to accidentally define open in a way that is closed, right? That makes it okay to never have a conversation with other people and do it all secretly in a room or something.
More has it.
Yeah, just to follow up on the question of open source software and reproducibility and the points that were made by Reed about maintenance. I'm a more peer, I'm at Yale University. We do reproducibility checks on the research that our researchers produce before we share their results. And just anecdotally, so this is in reference to statistical software. In our reproducibility checks, we find that basically the two main languages that people or software that people are using are R and Stata, and it's easier to reproduce in Stata. So even though we are big proponents of open source, we want people to use R. What are the costs or the burdens for reproducibility when people are using R in this instance? So maintenance is a key topic and a key requirement in order to continue to be able to reproduce the research.
Can I ask the speaker from Yale what group you're in that does the reproducibility checks?
I'm in the Institution for Social and Policy Studies. We are a research center in the social sciences.
Thank you.
And yeah, Malvika? Sorry, Richard, I'm sorry. You want to call him Malvika?
Yeah, thanks, Richard, and thanks, Stephanie. I was very excited by the comment on open source, and I wanted to be sure that we all are kind of understanding the relationship with open source and reproducibility. In a lot of sense, the reproducibility and open science have high correlation, as in that if it's too close where you're not sharing anything, it's very hard to reproduce. If you're going in the gradient where you're sharing code and data and containers in order to reproduce, that openness actually correlates into higher reproducibility. But I also see that open science or open source can be taken as next step to reproducibility, because reproducibility does not require that you do share everything. But for instance, reproducibility will ask, is my code correct or is my data correct? And open science will ask, is my code correct and data correct? And is it really available for someone else? Reproducibility will ask, can others read and test it? And open science will say, oh, can I modify it? Can I allow someone to build on it? So also thinking about, is the workflow robust? Open science will say, is it reusable in any other context than where I have developed it? So a lot of things around reproducibility can also be that, can someone cite it when they're using my work? And open science is about, can I collaborate with them and work with them rather than just leaving it on them? So there's a lot of collaborative element that open science allows reproducibility to actually, go further, a step ahead. But also thinking about open science, I feel like when people say, oh, we have to define open source and open science, my brain is like, well, that's not possible. Open science is really, really relative term. It's contextual to where you're applying it. Open in one context isn't really open in another context. And I think we can talk a lot about why open science also emphasizes so much on equity and inclusion of different people, because it's not enough to say that I have opened up for my colleagues, or a lot of time right now. So I am in one of the panelists in NASA TOPS, and NASA TOPS is strictly funding it for the US researchers, even though of course they know when the things will be open, it will be available for rest of the world, but they cannot on record ever say that their work is going to benefit anybody outside the US, which means that by design, a lot of the things that they will develop will not take into consideration, is it accessible outside the US? Does the policy outside the US actually affect the work that we are doing? So I think if we as researchers decide that I would actually worry about that, irrespective of my national policy allows me to do that or not, because it's a researcher's responsibility to actually think about ethically if the work is going to harm someone outside your own context, or is it going to benefit? It's really, really up to us. So thinking about reproducibility as something that is actually helping you think towards open science. So they are not the same, but they are also not separable from each other. But also talking about open source, it should not be defined. It should be treated as a framework that people can use and apply to the degree that they are able to.
Reed and Kirsten.
I think Kirsten might actually have a rebuttal or.
Yeah, I want to frame an agreement with Mavika in the sense that it's not these like fixed definitions, in the sense in that it's like but if you open as a modifier when applied to a noun, the moment you put them together, now you've got if we haven't solved for that domain now needs to be solved for. What does openness mean in this domain? Because it had like open data, and now you've got privacy laws, you've got this whole other new realm of things you brought in. So I don't know if that helps to kind of balance, because I wanted to definitely acknowledge what Mavika was saying about that's not, you can't having a fixed definition for something that's so fluid, but it's also useful for us to be counteracting against the anti-pattern uses of openness, where people are the open washing and things like that. So somewhere in here is a balance to make sure that with this we're all moving in the same semantic direction.
Yes, I like the point about Reed here. So I like the point about how openness, all of these terms have to be contextualized, right? They all have to, but at the same time, language has power, and we need to build consensus, right? So especially when we're talking about inclusion with teams of many disciplines, right? So a multidisciplinary team without differences is a contradiction in terms. Right? We expect that we have lots of different people coming together. Of course, they have lots of different beliefs about what things should be, what their ideals are, what their values are, what they want. But we need to have some consensus on the terms we use. Otherwise, we can't communicate, right? And openness should mean something. There should be a test by which something is open or it is closed, right? So I like the idea of having definitions. At least it's something aspirational. I'm not saying everyone has to be open to that degree, right? But I do think there is a lot of power and unifying power in having a consensus around basic terms like openness. That would be my one point on that.
Zach.
Thanks. A lot of I thought I had this settled years ago, and thinking in terms of really practical terms like licenses, free software, and the SFF community, GPL community, and versus more permissive licenses. And so like that kind of constrained my thinking as being kind of tactical, practical. I met a researcher at Stanford recently who kind of got me thinking differently about it, framing open source as not so much about distribution, which is where I was in license land, but more about the mode of production, that it's inclusive and participatory. And I thought that was pretty interesting.
Sam?
I was actually going to ask a licensing question.
Okay.
If you have any more to say on that. The utility of licenses as a way of kind of flashing open, and whether, that's what we often advise researchers to do, to license at the end of opening their data, opening their code, their software. But how useful is it? And Zach, you kind of answered that anyway.
Did anybody else have, anybody else have?
This culture.
Sayeed has a comment.
Yeah, anybody, I was gonna say, I thought that might be something others might have a comment on.
You look great, but you're muted.
Yeah, thank you. Well, I made it almost to the end before doing that. I actually have, it's related to this, but it's slightly different directions, if that's okay. Again, I wanted to ask, people in the room and online, this idea of openness. I think one of the most frustrating things for me thinking about AI is that the company behind ChatGPT called itself OpenAI. So I'm trying to think of another term. So openness in AI, let's go with that for the moment at least. One of the other conversations, probably not surprisingly happening at CMU, is around AI and what should be open, right? There's actually a fair number of conversations on responsible AI, ethical AI, but not openness, again, for lack of a better term. Not as many around the openness of AI. And so when Meta or Facebook says, oh, we've opened up our large language model, what does that mean? What does that actually mean? And again, for how long? And so on. And I'm wondering if your community has done this work or has some ideas or has some pointers in terms of thinking about this from the reproducibility and replicability perspective, because that would be a very powerful one, right? Is if your community were to say, we need openness in AI in these ways to foster the types of reproducibility or replication that we need, that would be very important to convey to folks who are thinking about this, again, at the federal, sort of policy level, because I'm not sure what other kinds of framework or scaffolding we have at the moment to have a sort of structured conversation around this, but because of that connection between open science and reproducibility as laid out in the White House documents. If this community could say, you need to have openness in AI in the following ways to support the types of things we know are important, that could be a really powerful lever.
I wanted to comment, which is strange. I just can't not do it. So I come from linguistics as a background, and linguistics has a whole ton of different weird ethical issues where a lot of minority languages don't want their stuff out there. And you have to do a lot more ethics involving data. And open data in linguistics doesn't mean the same thing as open data in computer science. Doesn't mean the same thing as open data in like legal studies. Doesn't mean the same thing. And when you think about the OSI, they're really, really good at defining open source, but only defining open source according to their own weird definition that has to follow these really, really clear things, and then excludes a whole ton of Big Ten open source stuff that we have issues with. Things like ethical source, which I think is fantastic in that it stops, say, ICE from using code, but is really, actually limiting usage, and so isn't an open source license. And I just wonder, I want to go back to the balkanization of these terms to each community. It's going to be relevant, which means that when we're talking to national labs, when we're talking to policymakers, we have to say, we're going to use the word open, but we're going to add an asterisk. And the asterisk is going to apply to each subcommunity. And we're listing the ones that we think are most relevant here. And that's, I think, future work that we need to do before we can even come to the whole idea of AI. Because AI doesn't talk about what communities it's impacting or where the data sources are coming from. All it talks about is the method being used to draw data from one place into another place. It's a big shim. And so I just think that's a big open question that I haven't seen addressed enough. And it's something I would like us to touch on more in this community here, because we're the people who are the vanguard of trying to figure out, okay, what does open mean, when, where, and why? So thanks for letting me butt in for a few seconds.
Yeah, no, I agree completely, Richard. The only thing I'd add is a point I made earlier is it will be potentially easier for us to start with open and close it. So for example, if I'm just making this up, if from a reproducibility perspective, we say the following types of data need to be open, or the following types of machine learning models need to be open, and so on and so on. We can then layer in wait a minute, that's an indigenous group of people, and you can't do that, right? There's other considerations. But starting with that foundational, what do you need to reproduce the work that's being done by incorporating AI into research could be a really powerful starting point, maybe.
Thank you. Malavika?
Response on that is that in a lot of open science conversation, we're also kind of always referring to responsible open science, as in not open for the sake of openness, or not open when it harms people, or not open when it exploits people, right? When are we responsibly opening things? And I think that applies to AI as well. I think a lot of conversation around even ChatGPT or OpenAI or Meta work has been around how much responsibility do these organizations take on the use and harm of the technology. So open and responsible AI, because responsibility is a lot more easy to understand and you can actually define it. I wonder, Richard, what your linguistic mind says about it. But I feel like transparency, responsibility, and quality, maybe quality is also relative, but these, rather than saying open, we can really move towards being like, is it responsible? Are we taking responsibility for the safety of our users or safety of our community or people who should be impacted by it? Are they involved in the development of it? Are they able to investigate the code that we have? Are we telling them where the data is coming from? The problem with this big, large language modeling and AI technology is that we're not told where the data is coming from. And we all know it's our data, it's scraped from the internet. We have contributed to it. It's kind of scary when I ask questions that I would be generally responding to, and it sounds like that I have written it. In a way, sometimes one of my colleagues says, should we not just write really nice and kind things so these technology actually are nice and kind and replicating our behavior rather than being really harmful and horrible?
Just to read here, so just to Saeed's point, I want to mention that we owe OpenAI a great deal of credit, a great deal of appreciation. No longer do we have to deal purely in hypotheticals about moral and ethical transgressions against the idea of openness. They have done it for us, right? They have shown us that our definitions are not good enough because clearly they ain't open, right? But I think I like the point though about AI. AI is a perfect example about why we need to come to a consensus about these terms and definitions of openness and reproducibility and everything else. Because here we have a technology that will directly impact society. Here we have something that could have tremendous positive and negative impacts. And it seems like an ideal opportunity for talking about AI to talk about what these words even mean, right? So I like the point specifically about AI as a really good exemplar for this discussion. Just want to point that out.
Oh, and we have another question on the floor from me.
Yeah, I'd like to go back to also what Sayeed was sharing earlier and that other panelists have discussed, is that at this point, when the questions you ask, like what does it mean OpenAI and what do we need to make this OpenAI, the questions are pretty similar to what do we need to make AI models reproducible? So what do we need to give access to? So at this point, the two definitions sort of merge when you put them in that question, although it can be pretty clear that you can do reproducible work, or can you do reproducible work without making it open? That is within a closed community, a community that would be maybe behind a firewall, but they would be large enough that you could still do the reproducibility question, and you would make these definitions of, what is it that you need to share in order to be able to make this AI open. And the additional point or comment I would like to make also, and it applies much more, I think, for the use of AI in the physical sciences than than with large language models, is that there's the question of explainability. So can you actually explain how AI has achieved this particular results? And in the physical sciences, of course, they have equations. So can we potentially say that the predictions is working in this particular way because it used a particular term in an equations and it changed it, or it made it different, or it kept it along? And so I don't know if that would work for large language models. maybe not, but for use of AI in physical sciences, then the terms that you use for explaining how a particular prediction was achieved can also be part of what is making it open.
Thank you. I think that should be the last comment, and I'm saying that because we have 5 minutes less in this session, and I think making people sit for 90 minutes is criminal. So, Stephanie, unless you have anything else you want to add, I think we should probably wrap this up.
No, I think, yeah, I was supposedly getting the last word in based on the conversations we had with this, that I said, well, that I guess I shouldn't have missed that meeting where that decision was made. But no, I think all the comments really came out well. I mean, I think that just like I said, there was a link when I felt there was an interesting parallel between the reproducibility discussions and the open source discussions I was hearing. And especially over the last day, and a lot of the panelists weren't party to some of the other earlier discussions. And I thought one that really resonated with me yesterday was when Juliana was saying making reproducibility. She said, I even wrote it down, just making it easy. And that's a lot of the discussions that we had with open sources, also making it easy. And in the easy, my understanding of that as a non-technical person is making it accessible, making it inclusive. And I think Malvika had a lot of points about that I thought was really good. So I guess that's my takeaway from the discussion is also that's a really key point for all of us, which I don't know if you do a Venn diagram where you hit where that comes for the open source and reproducibility folks, but I think it's a pretty big, group that overlaps, that the importance of the inclusion and accessibility that we are seeing from both groups, and how that also overlaps with a lot of the discussions of open science that I wish our colleagues from OSI were here today and hadn't were here yesterday, because they probably would have also had some input on that. So, but yeah, no, I think it was a really good discussion, and I don't want to leave everybody wants a chance to go get some coffee and beverages. But does anybody else on the panel have any last words? Or Richard, do you want to wrap up?
I think you did a pretty good job. I just want to thank all of our panelists for coming and joining us today. And thank you for organizing the panel, Stefan.
Thank you, everyone.
Yeah, thanks, everyone.
Thanks for having us.
Thank you.
All right, thanks, everybody. All right, we have an hour break. And for our last session, bye, everyone. Thanks.